Well, we have a question here, question 2. The question says that given the geometric sequence 3, 2, k, I'm going to write the question here. Question 2.1. Okay, we have the geometric sequence 3, 2, k, etc. And then question 2.1 says write down the value of the constant, the common ratio. Okay. I'm going to write here 2.1.1. So we're looking for R. R is the common ratio, okay? So because here they said geometric sequence, we understand that there is a common ratio here, R. Now, R is given by Tn over Tn minus 1. That's the common ratio. So this simply means that I can take any term, but I prefer to use the terms that are defined. So I'm going to take this term and that term. So I can say R will be equal to 2 over 3. So R is 2/3. Okay. I don't want to say that R equal to K over 2 because I will have to find the value of K. So I won't use those two terms except the one I selected, underline. Now question 2.1.2. This question here, the question says calculate the value of K. Now, so over here we're looking for the value of K. Then still using the same constant ratio formula, which is given by, as I wrote there, R equal to Tn over Tn minus 1. So this will be, this means that 2 over 3 will be equal to K over 2. So because it's any term, okay, divided, so I take this term, 2 over 3, and then I equate it to K over 2. Now, we can solve this if we apply the cross multiplication property. So we can do 2 times this 2 there, and then 3 times K. So 3 times K is equal to 3K, and then 2 times 2 is 4. Now we can find the value of K if we divide both sides of the equation here by 3 there, and then we get the value of K. K will be equal to 4 over 3. 4 over 3. So that's the value of K. Okay, because 3 over 3 will be 4. Now, excuse me. The following question is question 2.1.3. The question says, hence or otherwise, solve for n if Tn equal to 128 over 729. So 2.1.3. So we are looking for the value of n if Tn is equal to 128 over 729. All right. In this situation, I prefer to write 128. Okay, first of all, let me write the formula for the terms. The geometric sequence, okay, is given by Tn. Tn is equal to a r to the power of n minus 1. Okay. So I'm gonna do over here. A is the first term. A is the first term. So over here, A is equal to 3, the first term, and then R will be the constant ratio, which is 2 over 3. So therefore, Tn will be written. Tn will be given by 3 times 2 over 3 all to the power of n minus 1. And Tn is also given by, as we see there. So now I'm going to move my board here. Over here, so let's just split. Okay, so I'm going to equate the two Tn's. I'm going to say Tn is that, Tn is also that. So I'm going to say, in other words, it's like 3 times 2/3 to the power of n minus 1 is equal to 128 over 729. Okay, so what can we do here? Let me first write. I can see immediately that those numbers are like I can write the numbers on the left hand side, on the right hand side, in terms of the prime factor, because I can see 128 is equivalent to 2 to the power of 7. Okay, if you're unsure, and then 729 is also 3 to the power. If you're unsure, you can use a calculator. I can show you now. Open a calculator like this. We can just press write 128, and then press shift fact that button and then equal. Oh, sorry, not exactly like that. Oh, sorry. Rather, you press 128, and then in the calculator you press equal like that, and then you press this button shift, and then you get here by fact. You can see fact there, and then you hit fact, and then you got like 128 is 2 to the power of 7. Okay, similarly, excuse me. Okay. Similarly, we can also 729. You're welcome. 729. You press equal, and then shift, and then fact. That makes 3 to the power of 6. So this can be written as 3 to the power of 6. So now what next can I do? Okay, we can continue. You see, now I want to get rid of the 3 that I have here. This value 3 there. What I can do, I will divide both sides by 3. I divide here by 3, and I divide all these things here also by 3. Okay, and by doing that, I will have like 2 over 3 to the power of n minus 1. This will be equal to what then? You know, when I divide by 3, divide by 3 both sides in a fraction like this is similar to say it's similar to say times this side, the denominator here by 3. It's the same thing. I mean, this is the same thing. So this will be 2 to the power of 7 all over 3 to the power of 7 also. Okay, when I divide both sides by 3, check this out. The calculator will get the correct answer there. Then this will be 2 over 3 all to the power of n minus 1. This will be equal to, okay, 2 to the power of 7, because the exponents are common. The exponents here are common. I can just write it like this. 2 over 3, okay. Let me just write like this in the brackets, 2 over 3 to the power of 7. Okay, there's a law that says a to the power of m over b to the power of m. This is equal to a over b to the power of m, one of the law of exponents. And now the other law says that when the bases are the same like this within an equation, then this implies that the exponents will be equal. And then this, you can notice that we have like 2 over 3 here and 2 over 3 there. Okay, so this implies that n minus 1 will be equal to 7. Now we can work out n if we move 1 over, and then we have like n equal to 8. So that's the value of n. Thank you.